So a lot of college algebra students come in with a fundamental misunderstanding of both exponents, but especially square roots, otherwise known as radicals or expressions with radicals. Um, I want to go through the basic fundamental understanding and try and help fill that gap for any of you that might still be struggling with this idea. So the square root of any number, let's take 100 for example, is talking about what is the number that you multiply by itself to get 100. Well, because 100 is a perfect square, we can rewrite 100 as 10 squared. And that's just another way of writing 100. 10 times 10 is 100. So the square root of 10 squared is 10. Now, we assume when we're shown this radical symbol, it is assumed and dedicated to being the positive root. If we need a plus or minus, we put a plus or minus in front of it. So sometimes when we take the square root of something, that means we will need either the plus or minus. But when we just see a problem with the square root symbol, then it is assumed to be the positive root of that. It's by agreement among math people. So the way we write that in general terms is that the square root of a squared, where a is any number, just a number, we say that the answer is the absolute value of a. And the square root and the square are like, they're opposite to each other. It's like multiplying and then dividing again. It's like adding and then subtracting. Well, it's squaring and then square rooting, and you're back where you were before with a, but it is assumed that it is the positive, therefore we call it the absolute value of a. What's another way of looking at that? Well, another way of looking at is at saying, well, this box has an area of 100. Okay, great. Well, the square root of 100 is the length of the side of the square that makes the area equal to 100. Well, if we wanted to know what each side length of this square was, we know that 10 times 10, area is length times width. 10 times 10 is the way to make this a square with equal sides that has an area of 100. So similarly, if I said that the area of this box is x, then the square root of x is the square root of x. This side length is the square root of x. And therefore we can say, well, the area, in this case, we know the area equals the length times the width, right? Our area is x, by definition, we just called it that. And the length of our box is x, the square root of x, and our width is the square root of x. We can also write that as the square root of x because it's times itself squared, and this is x equals x, right? So the square root of x squared is x because they undo each other, the squaring and the square rooting. I hope that helps you understand a little bit about how that works. Now I'm going to talk about how to do some sample problems that involve square roots. So for example, on this problem here, 2x squared plus 2y squared plus 8x plus 7 equals 0. There are a few things we can do, and then there are a few things that I've seen you guys try and do, and I would like you not to, because it doesn't work. But for example, we can subtract 7 from both sides. We can add and subtract however we want to, as long as we do it to both sides. Addition and subtraction works just great. So we end up with 2x squared plus 2y squared plus 8x equals -7. That's fine. That's all well and good. Another thing you can do is you can divide something. You can divide the whole left side by a number, and as long as you also divide the whole right side by a number. And that's perfectly fine. We could also multiply the whole left side by a number, but again, then we would have to put something in parentheses, right? And multiply and make sure to distribute, okay? And in this case, we're going to have to make sure we divide each of these terms by 2. So we're going to end up with x squared plus y squared plus 4x equals -7/2. We can call that 3.5. -3.5. Now, something that you cannot do is, if you want to take the square root of both sides, that is not the same thing as taking the square root of each term. So, for example, if we were looking for the intercept of this relationship, and let's say we wanted the y-intercept, so we're going to set x equal to 0. Well, that's all well and good. We set this equal to 0. We keep our y squared. We set this equal to 0. And that's just fine. But now these can go invisible because they're zeros, and we have y squared equals -3.5. And now we can, in fact, take the square root of both sides because both sides are just factors. It's a single term. All right, so the difference between the word term, a term is something separated by a plus or a minus. A factor is something that is multiplied or divided by. These things are factors. This is just a string of factors. This is a factor, this is a factor, this is a divided by factor, but all of this is either multiplication or division. There's no addition in here. A term is something that's separated by plus or minus. So in this original equation, we have 1 term, 2 terms, 3 terms, 4 terms. We have 4 terms to the left of the equal sign and a single term on the right. This term here, 2x squared, has 3 factors, 2, x, and x. Because x squared is just x times x. So if we're just talking about using multiplication, it's 2x and x are the factors of this term. All right, so now we've got a single term on the left and a single term on the right. Now is the right time to take the square root of both sides. And when we do that, we get y equals, and we need to pay attention to, we like that it's either plus or minus of the square root of -3.5. But the problem, has anyone seen the problem yet? -3.5, take the square root of that. Look back at this box. That would be like saying that the area of this box is -3.5. What is the length of a side? That's nonsensical. A negative area doesn't make any sense at all. Well, that's because when you take the square root of a negative number, square root of -1 is defined as I, which is to tell you that you are in imaginary numbers. So there are 2 major groups of numbers in the world. There are the reals and there are the imaginaries. And the real numbers are what we graph in. When we have anything with a square root of a negative that makes it imaginary, we can't graph it on a real number XY coordinate plane. It is an imaginary number. So we say that there is no answer here, that y, this is an imaginary number, so there is no real solution to this, which means that this circle does not touch the y-axis. We set x equal to 0, so this is the x equals 0 line is the y-axis. This circle does not touch it because there is no y-intercept. So what you need to take away from this is, if you end up with a solution where you are taking the square root of a negative number, know that that means you do not have a real solution, and therefore there isn't an intercept for that problem. Now I'm going back to where we just had divided out the 2 here and moved our constant over here, because I really want to stress that I've seen several people make this mistake. I want to make sure you guys don't make it again. What some people do here is say, look at these squareds. Why can't we just get rid of them by square rooting this side and square rooting this side? And then we just have x plus y plus 2 square root of x equals the square root of negative 3.5, which is still nonsensical. But that is not true. This does not equal this. And I want to show you why on the next page. Say, for example, we have the square root of 2 minus 1. Now notice I have 2 terms, not a string of factors, but 2 terms within this square root symbol, within this radical. What does that equal? Well, by the logic that some people were mistakenly using, they'd say, well, that's the same thing as the square root of 2 minus the square root of 1. Well, let's see, is that really the same thing? Well, 2 minus 1, you might notice and realize, is just 1. So clearly, if I simplify just within the radical first, I would get that it should be the same thing as the square root of 1. Now, does that equal the square root of 2 minus the square root of 1? Well, the square root of 2 is approximately 1.414, and square root of 1 is 1. So over here we have the square root of 1, which is just 1. Does that equal 1.414 minus 1? 1 does not equal 0.414. And this is for exactly the same reason as we can't take x plus y squared. We cannot call that x squared plus y squared, because it's not. It's x plus y times x plus y, which gives us, if we FOIL it out, x squared plus 2y plus y squared, which is not the same thing as just x squared plus y squared. Last thing I want to tell you, and I use this as a trick whenever because I still get befuddled by square root signs and radicals every now and then. And what I've chosen to do, because I've become more comfortable with the exponent rules, like the squaring and cubing and things here, I take my radical, if I have 2 minus 1 to the square root, that's the same thing as 1/2. So the square root of 2 minus 1 is equal to 2 minus 1 to the 1/2 power. Now, if I look at it like this and treat it the same way I treat things like squared, granted to the 1/2 I can't easily write out 2 minus 1 times 2 minus 1, but I can think of it as, what do I multiply by itself to get 2 minus 1? And that's what the square root means, that's what the 1/2 power means. But if you're just manipulating things algebraically, you should maybe consider learning to write radicals as fractional exponents, because that's exactly what they are, and they follow the rules of exponents.